Hi HPC, we're on day 5 of limits. So this one's a really super easy one too. This is talking about limits when there are asymptotes, both types, vertical and horizontal. So remember that we have two different types, vertical and horizontal. And remember that the places we go to find the vertical asymptote is in the denominator. And for the horizontal is those three cases. Right? And I call it battle of the x's, which x has the highest degree, okay? So taking a look at these, we're gonna do a couple examples that have these. Now, how do I know that these are gonna be the asymptote ones? Well, there are rational functions that we just finished with. So they're gonna be ones where there's x's on the bottom of the fraction bar if you get the equation. If they don't give you the equation, they just give you the picture, they're gonna draw in the asymptotes. So you would know that way. All right, let's take a look at our first one. And our first one is 1 over x plus 2. So the very first thing we do is we look at it and we check to make sure it's been graphed the right way. So we do x plus 2 equals 0. So there should be a vertical asymptote at x equals -2. And here it is, right? So we're happy with that. Okay, then the next step we would do is we'd do HAs. So HAs are battle of the x's, the bottom wins. So when the bottom is a greater degree than the top, then we have y equals 0. And sure enough, we have y equals 0 is our horizontal asymptote. There it is. Okay, and then we would try to find, like, if we plugged in x equals 0 into the equation, we would have gotten 1 over 2. So at 0, we should have a 1 over 2. There it is, right? And that would have helped us find this little L shape over here. And then we probably would have had to try an x that's on the other side of the vertical asymptote, like maybe an x equals -3. And then plugging that in, we would get a 1 over -1, which is -1, which would give us like this point right here. And then we'd find our two L shapes. So just a quick reminder on how we do graphing of rational functions. Okay, so this is asking for limits, and it's asking us specifically to look right where the vertical asymptote is. Okay, so they're saying, what is the limit as x approaches 2 from the left? So from the left side, if I draw my stick figure person, approaching -2 from the left, they are walking this line that is going downhill. And as they go downhill, what happens? Well, they're just going to keep going downhill forever. Well, what number do we use to represent going downhill forever? Let's call it -infinity. So the y is going towards down forever. That seems reasonable, right? Okay, so then let's go and look at the other one. So this is -2 from the right. So if I go from the right-hand side of -2, I am this stick figure over here, and I'm no longer walking downhill, I'm actually walking uphill as I'm coming from the right towards x equals -2. And it looks like here, I'm just gonna keep going up and up and up and up. And I need a symbol to represent that I'm gonna go up forever. You got it, it's gonna be positive infinity, or you could just write infinity, but the positive makes it super clear. All right, so here's the new difference is, remember before that if in order for it to have a limit at the same number, the two signs have to match, the two numbers have to match. It has to be the same number from the left as it is from the right. Infinities, if there's positive and negative, are not the same number. One is a very, very humongous negative number, and the other is a very, very humongous positive number. They are not the same number in any way, shape, or form. So when we ask for the limit, we would say they do not match, and it's D and E. There you go. Easy, right? Okay, let's just try two more, and we're pretty much done. So this is not too bad. All right, so here I'm just going to double check. We have our vertical asymptote in the right place. There we go. So that's our vertical asymptote is x minus 4 equals 0. That means x equals 4 is our vertical asymptote. We have our horizontal asymptote, battle of the x's, the bottom wins again. So we are looking at a horizontal asymptote at y equals 0. And then we just start randomly plugging in some numbers. So if like I plug in an x equals 0, y would be a 1/16, so almost 0. And 1/16 would be just barely above. So it looks to me like we're going to have one that is kind of going this way up to here. Okay, and then for the other side, I'm going to have to try something on the other side like a 5. So if I do that, I'm going to get 1 over 1. So at 5, I should be at about 1. And we can see that the L curvy shape on this side is going to be something that goes this way as well. Okay, so quick sketch of our graph. That was easy enough. All right, so let's take a look. So we are looking at +4. So we are looking at this vertical asymptote right here. And they're saying from the left. So if I'm going from the left, we're doing this part right here. And that would be positive infinity. Okay, if I'm going from the other side, From the right-hand side. So again, the first one was from the left, right? Negative means from the left-hand side. The second one is from the right, from the positive side. So from the positive side, I'd be over here, right? I'd be walking this way, right? And I'd end up going uphill. Okay, so this is positive infinity. So what do I write here? Are these allowed to be the same or not? So in this case, because they're both going to the same location, they're both going uphill for a really long, humongous positive whole number or positive numbers, we're allowed to say that the limit is positive infinity because both sides agree. So we're going to say that that's positive infinity. All right, so let's go down and try our last one, number 3. I've already graphed this one for you so that we don't need to worry so much about it, but let's just double check. So we have our vertical asymptote here at 5. We have our horizontal, ooh, look at this one. For horizontal asymptotes for this one, battle of the x's, it is a tie. And if it's a tie, we're going to take the coefficients in front. So that's -1/1 of the highest power degree of x's. So that is at y equals -1. So that's why we've got this one down here, right? And then we would have gone and tried to plug in an x is 0. If an x is 0, we would get 0/-5, which is still 0. So we know it goes through here. And then I would have to pick a number on the other side, which would be like a 6. Try an x equals 6. Ooh, come back. Try an x equals 6, and we get -6/1, which would be a -6, which would be somewhere down here, right? So that's how we kind of graphed it, okay? All right, so let's take a look and see what we have for our limit. So as we're approaching this vertical asymptote from the left, I can see that as I'm drawing my stick figure, right, they're going uphill, they're going towards positive infinity. Okay, if I try the same thing from this side, I'm drawing my stick figure here and here, they are going this way, they are going towards negative infinity. So do I have a limit as x approaches 5 from both sides? No, this would be a D and E because they're different places. That's really pretty much it. The only thing is, I don't know for sure when you see a problem like this, are they just going to give you the picture and show you the asymptotes with the little dashy lines? Or are they going to give you the equation and you have to remember how to graph them to be able to get to this point, to be able to answer them? So it's okay for a limit to be going to positive or negative infinity, even on a one-sided, but also on both sides. If they're both going to the same infinity, same direction, then you're allowed to use that infinity symbol as your answer. All right, that was it. Again, we're right under 8 minutes. See you next time.